right, let's talk about the TI Nspire, and this one's going to be a lot of stuff in one video, but we're going to talk about how to find zeros, solve equations, how to store equations in your calculator, how to store the solutions to those equations in your calculator, and then finally, how to evaluate numerical derivatives. These are all things that you need to be able to do on the AP Calculus exam. If you want to print a sheet to kind of follow along for guided notes, you can go to this bit.ly link right there. And let's go on and look at some problems. I'm sorry, I forgot about this. This is these are the four commands or four functions on a calculator or graphing calculator that you must be able to perform on the AP Calculus exam. I covered number 1 in another video. In this video, we'll cover numbers 2 and 3. Number 4, calculate the value of a definite integral. I'm going to do in a separate video later on in the school year. My students have not yet gotten to antiderivatives and definite integrals yet, so I'll do that one later as I get to it with my students. So let's look at this. Let's look at this example. We have the function e to the sine x minus ln x, and I'm asking you to find the zeros of that function. So I'm going to go to my calculator, and the TI Nspires, if you have the CAS version, which I do, it does have a built-in equation solver that you can do on the calculator screen. However, I strongly recommend you do not use that and that you solve graphically instead. And I have several reasons for that opinion, but right now I'm going to spare you those reasons. And so I'm going to start by graphing this equation, e to the sine x minus ln x, and then I'll find the x-intercepts graphically. You can, if you want, use the scratch pad. If you press this button over here, it'll toggle back and forth between calculator and graph screen, and I do use that a lot because it's just convenient and easy to get to. However, for this example, I'm actually going to use a document, and I'll explain why in a minute. So we're going to add a graph, and the function is e to the x, and when you do an exponential function e to the x, make sure you use that e to the x command that is next to the 1, and I forgot to hit sine x, so e to the sine x minus the natural log of x is our function, so control natural log x. There's our function, and it looks like we have 3 zeros. However, the problem did state that we are to solve only on the interval 0 to 8, so I need to restrict my x-axis, and I'm going to adjust my window by clicking on the minimum x over here, change that to 0. If I tab around, it jumps up to my maximum y. I want to leave that where it is. My maximum x needs to be changed to 8. And I'm going to leave my minimum y, so I'll just go ahead and hit enter, and you'll see that third 0 actually went off the screen, and we only have 2 to find. And so 2 ways to do that. The first way, and this is available in the scratch pad as well, is to go menu, analyze graph, and we want the zeros of this graph, and when you click that, it gives you a dotted line. You click on one side using your touchpad over here, and you drag across, you click on the other side, and do remember in AP Calculus, all answers must be accurate to that third decimal, so you want to make sure you are seeing 3.036. If you don't see that many decimals, you can hover over that x coordinate, and if you press the plus button, it will add digits. If you press the minus button, it will take them away, but I can't think of a reason why you would want less accuracy. But you can add digits by pressing that plus button, and there is one of the zeros, and then we would have to repeat for the other option, for the other 0. I'm going to undo that, however, and show you how we can get both zeros at once. So I'm going to hit Control-Z to undo. Whoops, oh crap, it's going to make me undo all that. Okay, never mind. Control-Z usually works, but I forgot I added all those digits. So to get both of those at the same time, we're going to use actually the geometry menu, and the geometry menu is not available in Scratchpad. That's why I wanted to do this in a document instead of the Scratchpad. But before I go there, I'm going to escape out of here, and I need to actually graph a line on the x-axis. So I'll go up, I will graph the line y equals 0, and now that I have 2 graphs, f1 and f2, I can find the intersection of those 2, and those are found in the geometry command. Points and lines, and we want intersection points. And if you ever forget how to do this, up in the top left corner you'll see a little box. If you hover over that, it will tell you how to find the intersections, and you simply click on the 2 graphs that you want the intersections for. I will click on the blue one, I will click on the red one, and as soon as I click on that red one, it displays both of them simultaneously. So there's a nice convenient way to get your x-intercepts, or to get multiple intersections of graphs if there happen to be more than one. And notice that little box up here is still visible. That means I am still in intersection mode. So if you wanted to interact with those coordinates or anything, you need to press the escape button. And when I press that escape button, now I'm back to where I can like click and drag or do things with those intersections. And so the ways you get those zeros, one of them is to do menu, analyze graph, and zero. And then the other one, which I don't have blanks on this sheet for, is to use the intersections within the geometry points and lines menu options. Okay, so let's look at a different question, and this is these are functions that were used in the 2019 AP Calculus AB exam. Maybe it was BC as well, I can't remember. But we have two functions at play. We have the rate that fish are entering a lake, which is somewhat ugly. We have the rate that fish are leaving the lake, which is also somewhat ugly. It's not terrible. But we're going to use these functions for multiple questions. And when that happens, it's a lot easier to define them in your calculator as E of t and L of t. For first, it guarantees that you don't accidentally fat finger the equations as you keep putting them in over and over again. It also is a lot easier to store them. So I'm going to go back to my calculator, and I'm going to start a new document. File, new document. I do not want to save that previous problem. And I'm going to add a calculator first, and I'm going to define my E of t function. So I'm going to hit E parentheses, T parentheses, and over here next to 9, above this button, you'll see colon equals. I'm going to hit colon equals, and then you simply enter the equation for E of t, which was 20 plus 15 sine of pi t over 6. So I'm going to enter that very quickly, and then I'll come back and show you, we'll store L of t as well. Okay, I went ahead and stored both of them. One thing to look out for is when you are storing, if I say E of t colon equals, then you must use t in your equation. If you want to use x, that's fine, E of x, but then just remember to use x as your independent variable. Always double and triple check that you do store these correctly. One year I was working for your response question and I accidentally mispunched the button when I defined my function, and then I continually used that error throughout the problem, and I had all the wrong answers, but my setups were immaculate. So anyway, so I have those stored. So let's go back to the problem. And here you can fill in those little blanks right there for how to store things. And again, be mindful of what you're choosing for the independent variable. So those are stored. Now I want to find right here the rate that fish enter the lake when that rate is equal to the rate that fish leave the lake. And my mouse just died on me. Come on, buddy. Well, plug it in. Are we back alive yet? There we go. So we're looking for the rate that fish enter is the same as the rate that fish leave. Well, that's how E of t and L of t were defined. So I'm going to actually write E of t equals L of t. Anytime you solve equations on the AP exam, you absolutely must, even if the calculator is solving them for you, write the equation that generates the solutions. You never, ever, ever only write a solution. And I'm going to solve this graphically like I did on the last one. And so back to my calculator here, I'm going to add a page, control add page. I want to graph. And because I have these stored for E and L, I can literally graph them as E of X. And you must use X. I know I use T on my calculator screen, but we have to graph with X's on the graph screen. So E of X, and you can see it floating up there. I will tab. I will do L of X. Enter. And obviously we don't have a very good window here, so I'm going to go back to the problem and see if they defined anything for me, and we do have the domain 0 to 8. So over here, I'm going to change my x's to start at 0. Oh, come on. There we go. Start at 0. And I need to adjust my y's as well, so I'm going to tab up to my y, and I don't know, let's try... I don't know how high. Let's try 50. I'm just guessing here. And okay, that was actually really good. And then it looks like I don't need to change this one over here to 8, but I will just to stay consistent with what the problem suggests. And my y minimum, I don't feel the need to change that. And so move these out of the way. Move that out of the way. And so I want the intersection of those two graphs. And because there's only one intersection, it doesn't matter if you use the menu analyze intersection or if you want to use the geometry points and lines intersection here. They're both going to be about the same. I tend to like the analyze intersection. I don't know why, it's just what I typically use. So I click on one side, drag across, click on the other, and I can see that my solution is 6.2035. So I'm going to right? T equals 6.2035. You must be accurate to the third decimal. And on the AP exam for your SPOTS questions, they will accept the properly rounded or the conventionally rounded answer of 6.204. They will also accept what they call the truncated version, which is you just write until you get to that third decimal and stop. Both of those are acceptable answers. Anything beyond the 4 or the 3 is not read at all, even if it's wrong. So make sure those first 3 decimals are correct. And again, make sure you write down the equation that generated those solutions. Now, I am going to use that answer in the next question. If we skip on to the next question, it says find L prime of C. So we want to compute the derivative of L at C, where C is the time that the rate fish enter is equal to the rate that fish leave. Well, that's the C value we just found. And so I'm going to, on my calculator, I realize I have to use this answer to in the next question. So to store that answer, we click on it, move your mouse over it. Sometimes when you click on it, it just makes it gray. Sometimes when you click on it, it actually highlights it, and now mine seems to be stuck on gray mode. But make sure it's either gray or highlighted, and while it is highlighted, come over here and above var, you see STO with an arrow. So I'm going to hit Control STO, and it says, what variable do you want to assign to that value? And I'm going to use C. I'm going to hit Enter, and notice that X coordinate is now bold. And if I hover over it, it will tell you that that value is stored for C. Now, if I go back to my calculator screen and I just press the letter C, it will see the value that we have from that graph screen, and because of the settings I have on my calculator, I can see a lot more decimals. On my written work, I'm going to actually declare that C is equal to 6.204, because if I declare that in my written work, then from that point forward, I can actually just write the letter C. I don't have to write 6.204. So I now have that stored, and we're going to compute L prime of C, so I need to find the derivative of L at that point C. And to do that, on my calculator screen, I'm going to go to Menu, Calculus, Derivative at a point. Not just the general derivative, but the derivative at a point. And so, so when I click that, it then says, what variable do you want to use? And it really doesn't matter what variable you want to use. I typically just stick with X because that's what's pre-filled there. What value do you want to plug in? And I want to plug in the value of C, which I have stored, and I want to plug into the first derivative. I click OK, it pops up this template, and then you simply enter the function whose derivative you are evaluating, and I believe it was L. I want the derivative of L of T, but remember I said d dx, so I need to say L of X, such that X equals C. I'm in the habit of hitting Control Enter to force decimals, and I'm getting the answer of 12.3875. So I'm going to write L prime of C is 3875. And again, that can be rounded up, 12.388, or you can truncate that at 12.387, or you could leave it as 12.3875. Any of those would be acceptable because those first 3 decimals and all of those answers are accurate. So there's how you would compute the value of a derivative at a point. And I kind of got this sheet out of order because I didn't put the instructions for how to do that until I have 2 number 5s, until the next number 5. So I give you this function, f of x is x squared 4e to the plus 4e to the negative x plus the natural log of that. And I want you to find the slope of the line tangent to f at x equals 1. And what you need to remember is that the slope of the line tangent to f at x equals 1, all of that part right here, that's the same as saying find f prime of 1. Even though the calculator is doing all the heavy lifting, you must write down on your paper what you are doing in your calculator. Not necessarily in calculator syntax, but just write down what you're doing. We are computing f prime of 1, and the next thing I will do is write down the answer. If you only write the answer, you likely will not get points for a question like this in a free response situation. I'm going to punch out in the calculator really quickly just so we can see what the answer is. I'm going to pause the recording while I do that, and so you can try it if you want and see your answer in a second. Okay, so here's my answer, 0.7186. And once again, you have the option of rounding up or truncating. I'm just going to leave it like this. And notice I did not define my function this time because there's only this one question. I don't have a whole bunch of questions using this function, so I didn't bother doing f of x colon equals to store it in the calculator. You can if you want to. I just punched it straight in like this. And make sure you hit Control Enter, because my calculator, if I did not hit Control Enter, would have given me this really long exact answer in terms of natural logs and sine and e and all that stuff. So just give the decimal answer if you have a calculator in your hands. Readers will greatly appreciate it. All right, and so I have one more problem on this sheet, and I'm actually going to make this another video, a third video in this little series, because this one, I'm asking for the second derivative, and I'm actually going to talk you through how to use the derivative command on the CAS-capable calculators. If you have a non-CAS calculator, this won't really apply. So I'm going to do this in one more video. So hopefully all of these things made sense with using your calculator to get derivatives and solve equations and all that. And have a great day.